Hello, today we are going to discuss about the acceptance sampling. Now, any production when you take something with quality and quantity, we have to have acceptance sample testing. Without that, you cannot perform the duties. Now, here we are talking here when production has already taken place, it is often necessary to know the quality level of the lot, because whatever you produce in a day, it has to be ensured that it is meeting all the quality requirements. And rejections are taking place, again we have to ensure the rejections which are taking place, they are within the norms. So each lot has to be tested, and we must make sure that there is a minimum rejections or minimum wastages, and that is only possible through acceptance sampling, which is the statistical quality control technique for making decisions. Because every figure, everything will come to you mathematically, statistically, every data will be available to you, and then with that you can calculate as far as the quality is concerned, as far as the quantity is concerned, and then rejection, the percentage ration, and costing and all will come into that way. Every aspect of inventory management will come into that way. EOQ will come into that way. All elements will come into sample acceptance sampling, and then with that you can form some yardstick. Now here, after we know what acceptance sampling is, I'm trying to show you one operating characteristics curve for a sampling plan when number is 100 and sampling, I'm talking number 100, and acceptance figure is C is equal to 2 here. Now see on the left side, x-axis we have got actual percentage defectives, and on the y-axis we have probability of acceptance per percent. Now here, see the graph where it is moving here, actual percentage, that is 8 goes into 100. Let's see, we'll explain this here. Now acceptance sampling by attributes. Attribute means sample size. We have taken sample size which is n. Number of defectives in the sample permitted C, that is I'm talking acceptance number, are indicated before the entire lot from which the sample is drawn to be rejected, because we have to take each lot into consideration, and we have to take a sample size, and we have to take acceptance number out of that, what should be, after taking out rejections, after taking out other factors into consideration. So once you decide the sample size, once you take the acceptance number, then this is what we will see the sampling, how it is done as per the graph. Thus the OC curve for the participate combination of N and C shows that how well the plan discriminates between good and bad lot. So you know how much is good, 99%, 99.9%, and how much is bad, probably 0.1%, 0.2%, 3%, so on and so forth here. So it will be only possible through this method, through acceptance sampling and taking lot and taking acceptance number, you will be able to find out the position of the lot. Now the above diagram is for n is equal to 100 sample size and acceptance number C is equal to here. Now less defects 2 in a lot size of 100 is acceptable. Now in 100, if you have defects maximum 2, then we say lot is okay, that means 98% results are there. If it is 3, then there is some problem. The problem will be with the equipment, problem will be with the manpower, problem will be about the materials, and so on and so forth. So with that we will be able to analyze here statistically what is the acceptance sampling norms which are to be formed here in that case. So this is where the sampling plan has to be made, and it's to be ensured that the quality is being maintained here. Now here, now keeping sampling into consideration, here we are talking producer risk and consumer risk. There are two things. One is a producer risk, that is manufacturer, and second is consumer risk, when somebody is buying it from you. So here again we are showing here on the x-axis we are showing actual percent defective in lots, and on the other side we are showing here probability of acceptance percent here. Now producer risk is alpha and consumer risk is beta here, and then we are talking here, just see the position, see the graph here, it is going, and we'll explain the graph here in this manner. Now producer risk and consumer risk, AQL, you have seen the graph here, acceptable quality level, lots of this level of quality are regarded as good. Then when talk acceptable quality level, that means that is good, because that can be accepted by the consumer, and the producers must produce that, and it is wished to have a high probability for the acceptance. So with that taking into consideration, the probability for the acceptance will be very high when you think of that way. Alpha, when we are talking here, is the producer risk minus the probability that lots quality level AQL will not be accepted. Usually alpha is equal to 5% in practice here. That is what the figure has been taken. So we must see that producer risk and the probability lot which are of the quality level concerned must be minimized so that we get the quality product here. Then we are talking LTPD, that is lot tolerance percentage effective, minus the dividing line selected between the good and the bad lots. Here we have divided the two things here. Lot tolerance means particular lot. Defectives, again I am talking here whether it is again 0.1% or 0.5% or 1% or 10%, whatever it may be. So each lot has to be taken into consideration with regard to producer risk and at the same time taking consumer risk into account. Then we are talking here next, beta is the consumer risk. Alpha was the producer risk. Now we are talking about this consumer risk. Beta, consumer risk, is the probability that lots of the quality level LTDP will be accepted. That is usually 10% is in practice here. Now consumer risk, when we talk of producers, we have seen two only, maximum 2 per lot. But when the consumer risk we are talking, we have said that that can be taken 10% in practice, because the items when they are produced, when they are stored, when they are shipped to the consumer, from consumer it goes to the individual users. So in that the percentage has been taken as 10% in practice, which should be acceptable. When the levels are so when the levels are set for each of these four values, two critical values points on the curve and that are determined points and as shown in the figure here. So that is how we take producer risk and consumer into consideration. Now again, every sampling plan which has been made, every rejection which has to take into consideration, every quality and quantity has to be considered. In that we have got specifications, we have to make specification. So what are those specifications? To specify a plan that meets the requirement for AQL and LT both. I am talking producer risk and we are talking consumer risk. And a combination must be found with N and C with an OC curve that passes through the points A and B as shown in the figure, and the mechanics of actually finding specific plans that fit can be accomplished by using standard tables, charts or formulas that results in the specification of combination of N and C that closely approximates the requirements set for AQLP and LTDB, both alpha and beta into consideration, taking sample size, taking the lot rejection, taking consumer risk and producer risk. Now specifications of again N and C I am talking for a single sampling plan. We have made one sample, we are discussing here what is to be done here. Now to specify a plan, it is necessary to determine the single sample size N and the acceptance number C that will produce an OC curve of, that is the operating curve, approximately that's specified by four values: AQL alpha, LTDP beta. That is I am talking consumers and producers both in consideration. This can be done referring to the Thorndike chart here. Now there is a chart which has been made here, so that can be taken and for an individual sample plan. Now example I am putting here, assume that the chart characteristics of OC curve desired have been already specified. Now what is specification here? We are talking AQL is 2%, alpha is 5%, LTPD is 8% and beta is 10%. So here are the examples, here are the cases which are taken into consideration for each lot, for each plan, and that is how we have to make the requirement here. Now keeping in mind here, basis for selecting sample, what are the basis? How do we do that? The specification which you are talking, how do we specify that? How do we choose the specification? Here we are talking the relative advantages. Now here we are talking relative advantages and disadvantages of alternative sampling plans. Do not rest on the protection from poor quality that can be achieved. The risks involved depend upon the OC curve of the plan and can be present, and a specific objectives are LTPD and AQL production can be implemented in all the three stages. What are three stages? Again I am talking producers, consumer and the specifications, sample plans. So this is how we must make the plan and we must select the samples accordingly. Now again basis for selecting sample plan, which have graphically it has represented here. See the presentation which has been given here. Again number of rejections, C on the y-axis, on the left side on the ground number inspections N, we have got rejection region, we have got lot rejection, and we have continuous sampling. This is how things will start producing, and it will carry on. Wherever the possible rejection will be there, there is a region for election that will go lot rejected, and then we have picking up the continuous samples and trying to ensure meeting all the quality requirements. Now here we are talking the whole lesson which has been planned here has given us various acceptance sampling plans, the producer risk and consumer risk, sampling plan and selection of same, in order to ensure that it has acceptance sampling plan, it has a producer's risk and consumer risk, and at the same time it has a definite ideas. Now before I convey thanks to you, I just want to bring back few things here. What are the few things here? We have completed the one paper on production and material management. Now in that material management, production material management, we have covered the first part was introduction to the subject, second part was product planning, third was product design and process planning, the fourth was break analysis and introduction, then break analysis and decision making. Then we got a plant layout location. We have a plant location model. We have a multi-plant location. We have a plant location trends. We have layout and facilities. We have got human factors in the job design. We have got production control. We have got inventory control. We have got maintenance. Then we have got quality control. Then we got control charts. Then we have got acceptance sampling. We have got methods analysis and work measurement. We have discussed time studies. We have discussed allowances factors. We have discussed dynamic purchasing. We have discussed purchasing organizations. We have discussed housekeeping and warehouse management. And lastly, we have come to cost control and cost reduction program. So the whole lesson, whole subject of production and material management is to ensure that the economically the goods which are produced, they are of the best quality, they are of the reasonable cost, so that you can compete in the market. It is not the local market which you have to meet the requirement, it is the global market. You have to see that your product is 100% quality proof, and then it is consumer must be satisfied, the quality parameters must be met, the quantity must be produced accordingly, the plant must be maintained, the manpower must be trained, and as a result you are able to meet the requirement of the market. The fluctuations will be there, and those fluctuations also can be taken into consideration. So with that, I would like to say thanks to everybody for this paper on production and material management. Thank you once more.